Chapter 5 functions, we are back at it, and let us jump right in. I mentioned at the end of that last video to make sure we understood that example from feet to meters and meters to feet, because we're going to have and be coding a problem just like it. This is all about muscle memory. When you look here at what we're being asked to code in this program, it looks identical to what we coded at that last one. We had 4 columns, we had feet, we had meters, then feet. This is the exact same concept, and it's all about developing muscle memory. So here it says, write a program that will convert Celsius to Fahrenheit and also from Fahrenheit to Celsius. Your program should have these 3 functions. Celsius to Fahrenheit, where we're going to send over a Celsius value and then have the function return, just a single line of code, return, and it'll do the mathematical equation, and it will return the Fahrenheit value. Another function, Fahrenheit to Celsius, we're going to send over Fahrenheit as the argument, as the parameter, and it will return to us the Celsius value. And then, of course, we will have our main program, which will solve all of this for us. So problem-solving phase, it's just like that last one. So this obvious first step before even moving on is really come to Thani and pull up that last program that you coded at the end of the last video. So here we have those 2 functions, feet to meters, meters to feet. We have our main function, and we noticed our main function, we made that header, right? We had to see what was the spacing of the various columns. We had our meters, which started at 20, and we had to increment by 6 each time. Here I see Fahrenheit's going to start at 120, and it decrements by 10, so that's going to be different. Our feet, we simply went from 1 through 10, including 10 with a step size of 1. Here the Celsius is going to go from 40 down to 31, including 31, a step size of -1. Interesting. So we need to be careful there. And it's pretty much the exact same program. So be comfortable with this. Make sure we understand that we're going to use Celsius as the looping variable. We're going to go from 40 down to 31. We need another variable, Fahrenheit, for this 3rd column, starting at 420, and we're going to decrement Fahrenheit by 10 at every step. We need these 2 equations, right? You don't need to understand the math, just copy paste it, basically. Use that exact code. And let's see. We need to know that this first column is going to be the looping variable. This 3rd column is going to be the variable Fahrenheit that we're setting, starting at 120 and decrementing by 10 at every iteration. And then the 2nd column and the 4th column are the conversions. We're converting the 1st column Celsius value to the 2nd column Fahrenheit value. And then the 3rd column, which has the given Fahrenheit values, we're going to convert those to their respective Celsius values. So let's just jump right in. Let's make a new program, File, New. Let's save this. And let's call it temperature conversion. Done. And we had length conversion previously. Now we have temperature conversion. And it should look pretty similar. Let's go ahead and make those 3 functions. So define, let me type up here, define, we have your Celsius to Fahrenheit, C2F. I'm being a little bit lazy, sorry. C2F, I'm going to send over a Celsius value. Some of you are like, I like the lazy. I'm just going to type return for now so Python won't shout at me. Define F2C, and I'm going to send over a Fahrenheit value, and I'm going to type return here again so Python won't shout at me. Define main, I'm going to make my main, and I'm going to, after main, going to call my main function, so call main to start the program. Main. All right. So it's always good to do this, right? We run it, no errors, nothing's happening because I don't have anything inside main, but this is good to just make that overall skeleton, and now we're ready to go. So what do we want to do here? Let's come right to the main. And let's see, we need to first start by making this header. So if you're confused on what to do, come back to here and say, what did you do in main? Well, first thing I made this header, right? So I'm going to do that exact same thing. I'm going to make this header. And what's going to get printed, though, is now we're going to print Celsius and Fahrenheit. Celsius. Misspelled that. Spelling these things are super fun, right? Celsius and Fahrenheit. And then this is going to be Fahrenheit, if I spelled that correct. And this will be Fahrenheit. Now, when I run this, though, of course, it's not going to look exactly the way I want it to look, right? Because these are larger words than feet and meters, and so the spacing is different. Well, I've already counted this, so I can save you the time. The spacing of one column is 14 characters. So instead of 10s, this is going to be 14s, 14s, 14s. I really hope you're coding this, and I should have said, pause the video, go code this up, and then come back. Do that. In case you were just watching, again, you have to kick the ball. You have to practice. You have to develop that muscle memory. Considering that this is an identical program, you should be able to, on your own, look at this length conversion program that you did, and then come over here and make your own temperature conversion program. I clearly don't need to code it. You're the one who needs to code it, so pause the video, try to code it on your own. Worst scenario, you struggle, you unpause the video, you play it, and you catch up. But hopefully you can code this on your own. So go ahead and pause it, and then when you're done, come back and watch what I'm doing. So here, these are all 14s. Let's now look at the spacing. Spacing looks better. Okay, so now we need to have a for loop here. Loop from 40 down to 31 and including 31. And we said the looping variable, we'll just use Celsius as the looping variable. So I'm going to say for Celsius in range 40 down to 31, including 31, which means down to 30. And we want to do a step size of -1. And now, what am I going to do? At every step of the iteration, I'm just going to print basically this exact same overall formatted line of output. I'm going to print that. But let's see, every single column has 2 digits. So instead of 14s, it's 14.2f. I'm going to copy that, paste it here, and paste it here. So notice, as always, I'm not putting 14 on that 4th column. There's no need. Now, if I just print that, we'd have an error because we're printing these strings. And here we need to print a floating point value. So we're going to print here the word, the variable Celsius. And we need to print here the variable Fahrenheit, which means we need a variable Fahrenheit. So make Fahrenheit and initialize it to, I think it was 120. Yes, we're starting Fahrenheit at 120. So Fahrenheit equals 120. And at every step of the loop, at every iteration, I need to decrement or decrease Fahrenheit by 10. So Fahrenheit minus equals 10, right? It's from 120, 110, 100, 90, 80, 70. All right, and it will make it down to 30 by default, since we're going to be looping this number of times. So what remains is just right here, we need to put the equation, and then right here, we need to put the equation. What equation? This. If I have a Celsius value, how do I get the Fahrenheit? It's this equation. We're going to take 9, divide it by 5, and multiply that result by Celsius plus 32. That's the equation. So this second column of data that we want to print the result of this equation. 9 divided by 5 times Celsius plus 32 will give us the resulting Fahrenheit value, which is what we want. Now, the third column of data is we don't want to print the word Fahrenheit. We want to print the actual value Fahrenheit. So I'm going to get rid of this string. I'm going to print the Fahrenheit value, which starts at 120 and gets decremented by 10 at every time. And then finally, the fourth column of data is to convert a Fahrenheit value to Celsius. So given Fahrenheit, use the equation to get Celsius. So here, it's going to be 5 divided by 9 times, in parentheses, Fahrenheit minus 32, times, in parentheses, Fahrenheit minus 32. And that's it. That's the code without using functions. So let me close the variables here. Let me zoom out just a bit so we can fit all of that on the screen. Now if I run this, if I did it right, without mistakes, we should have the correct output, and it looks as if we do. Right? We go from 40, 40 down to 31, 40 down to 31. The converted values is 104 down to 87.8. That all looks good. Fahrenheit goes from 120 down to 30. That looks good. And the Celsius values are from 48 down to -1. Cool, that looks good. So what remains is what? We simply want these equations to be up inside these functions. So here, the Celsius to Fahrenheit, meaning given Celsius, get the Fahrenheit value. We just want to put this up here, return that result. And here, we want to put given Fahrenheit, return that equation to give you the Celsius value. And so now I want to, inside this format function, I want to call the function, or call the C2F function, and then here I want to call the F2C function. That's all I want to do. So I want to print four things. I want to print a Celsius value. Then I want to print the result of calling the C2F function. So C2F, and I'm going to send over the Celsius value. Here I'm going to print the Fahrenheit value, 120. And then what's the final thing that gets printed is I'm going to call the Fahrenheit to Celsius value, and I'm going to send over Fahrenheit. And that's it. If I run this code, we should get the exact result. Hopefully this is what you came up with. If not, as you watch me code it, hopefully you've understood. Finally, if not, rewind, watch again, reach out, ask questions. But I think we're mostly going to be good here because this is really the same thing as last time. I mean, look at it. Why is it actually even one line longer? Let me see. Because I'm actually curious. Where do I have an extra comment? Yes, I commented my for loop here. So if I want to make them identical, let's put this comment over here. Or just make my own comment. Here we're going to loop from 1 to 10, including 10. So if you compare these two programs, they should look identical because they're basically doing the same exact thing. All right, so that was a good warm-up. Here's code basically showing you what I already came up with and what you came up with together. Some new concepts here, passing argument by reference values. In Python, let's try to remember that, in fact, every piece of data in Python is actually an object. A variable for an object is actually a reference variable that points to or refers to the actual object. Even something as simple as x equals 2, you would normally think that x is just going to, if I say x equals 2, you would normally envision that here's the memory, we have x, and inside it is this value 2. But that's not what happens in Python. What happens in Python is when you say x equals 2, Python's like, cool, I got you. And we start on the right side of the assignment. Python makes an object, it puts 2 inside that object, and then what's actually saved inside x? What's saved inside x is an address. It's an address of where that object is located in memory. So now what's stored inside x is that address, so x basically points over to that object in memory. Seems like overkill, but that's how Python actually works. So something as simple as x equals 2, an object is created, the value 2 is stored inside that object, and then the reference of that object is saved inside the variable x. And even in Thani, where can you see this? If I come over here to garbage, and I just type x equals 2, and now let me turn on view variables. Of course, if I run my code, we get this variable x equals 2. You might think, hey, 2 is what is saved inside x. Well, Not so fast. If I turn on view heap, so we've covered the stack area of memory. What is the stack? We talked about that last in, first out access policy of functions that are stored on that activation record, thus on that stack with their activation records. Well, the stack is where your functions are stored. It's an area of memory where functions are stored, those activation records are stored, just to hold the functions in their local variables. But all other pieces of data, all objects in Python, are actually stored in an area of memory called the heap. So check this out. When I debug this code, one little line of code, let's debug it. But now I have variables and heap open. So check this out. It's an assignment. We go to the right side of the assignment. Python says, cool, I see that you have a 2. So what does Python do? Just like I showed you here. Python is going to make an object and put the 2 inside that object. So now when I hit F7, we're going to, notice here on the heap, we have the value 2, and that value 2 is saved in memory at this address. 0x stands for hexadecimal. So we have this address 217.3c.78.0.112. That's where this object is actually saved. And so what gets assigned into X? Well, when I hit the F7 button again, you can see what actually gets saved into the variable X is that address, which is what I drew for you here. What gets saved into X is the actual address, not the number 2. And so same thing, we look over here, what gets saved into X? It's the address of that object in memory. And if we go to that object in memory, we can see that it has the value 2. Kind of overkill, but that's unique and cool to understand how Python works in that regard. So here's a question. When we call a function and we pass to that function these parameters, these arguments, what actually gets sent to the function? Does the address get sent to the function, or does the value that is saved in the object get sent? So does 2 get sent to the function, or does the address that is saved in X get sent to the function? The answer is Python uses what is called call by object reference. In short, what is sent to the function is the actual address that is stored inside X. Not the number 2, it's the actual address that is sent over to the function. And then in the function, we can then go to that address and get that value number 2. Also, in parallel to this, we need to know that some objects in Python are immutable. Immutable simply means they cannot be changed. So strings and numbers are immutable, which means what? That you can't change them. And you might be thinking, sure, I can change them. I can say x equals 4. I literally just changed x. What are you talking about? Not so fast, because if we debug this, look what happens. Here, we have the number 2. So Python on the heap, it creates an object with the number 2. It saves it at this address. That address is then saved into the variable x, right? Well, now look at number 5. On line 5, line 5 says we make a new variable 4, which is saved into a new space on the heap, and this is its address, ending with 0150. And now that address is what is saved into X. So X is updated. X no longer points to the object that has a 2. X is now pointing to the object that has a 4. But the point is that we created 2 objects here. We didn't actually change the number. We just made a new object with a new number. So objects that contain numbers, they are immutable. You cannot change them once they've been created. The same goes for strings. The contents of an immutable object cannot be changed. So here it says type the following code and then debug it in Thani using the debugger, viewing both the variables and the heap. And we just saw one that was similar, but let's do this as well. Let's type in the y equals x. And then we can print y. And let me zoom in here as well. Way in, really, really big. All right. So let's debug this. We get here, x is 2. So we come to the right side and we create this object of 2. It's going to be saved at that memory address ending in 0110. We now say x equals 3, which is what it asked us to do. Cool. We create the object 3. It's saved at this memory address ending in 0130. So now we're updating what's actually saved in X. If you notice now, what's saved in X is this new address. Well, check this out. Now I have Y equals X. So we come to the right side of the assignment and we say, well, what is currently inside X? You might say the number 3. Nope. What's inside X is an address. This address, which points to a memory location on the heap to an object that stores the number 3. Maybe overkill, but important to know these things. So now we're saving that same address inside Y. And so finally, when I want to print Y, we're going to say we'll go to this address and print what is at that address, which is the number 3. All right. So hopefully we understand that, even though it's kind of weird. Might be like a whole lot to try to process. But that's what's actually going on. So consider the following program. We have a main function, and then we have an increment function. And we call our main. Let's look at our main function. We say x equals 1, and then we print before the call x is, well, you would expect the answer to be 1. Before the call, x is 1. Then we call an increment function, and we send over x, which is 1, and then we print after the call x is something. Well, let's try to understand this. So let's look now at this increment function. And this is all tracing code, right? Being able to look at code and understand what is happening in the code without actually running it. So here in the increment function, when I call the increment function, I'm going to send over the value, well, I send over x, that address, but inside that address, we have the value 1. And so now we print inside the function before incrementing, n is 1, which is what you should expect. Now we increment n, and n now becomes 2, which is exactly what we also expect. And then we say inside the function, after incrementing, n is, and what is n now? N is in fact 2. So inside this function, make no doubt about it, n will be incremented. Whatever n starts as, here we're sending over 1, but if you sent over 5, n would become 6. If you sent over 13, n would become 14. You send over 1, n becomes 2. Make no doubt about it. But now what happens after the increment function is the purpose of this example. Look at this print statement here. After the call, x is blank. What gets printed right here? The answer is 1. After the call, x is 1, and we never actually changed x. So this is the output here. So before the call, x is 1. Inside the function, before incrementing, n is 1. Inside the function, after incrementing, n is now 2. But after the call, x is still 1. So the value that was saved in the object that was referenced by x, it did not change. Why did it not change? Because numbers are immutable. That's what's important. Numbers are immutable, and therefore it absolutely did not change. So some of you might be thinking, well, yeah, this was obvious. Why should this be, worthy of even a major discussion? Because this is a type of slide that is discussed universally at this point within Python, Java, any language. When you're talking about functions, this idea of changes that you make to variables inside the function do not persist outside of the function. And that's almost in any language universally. It's a very important concept to understand. Now, what makes this one a little bit easier to understand is the fact that we used different variables. So if I come over here to Thani, this is the exact same program. I run it, I get that output, right? So we have, again, a main. We have x is 1 before the call, x is 1. We increment, we call this increment function. We send over 1. So, right, this would have been the actual parameter 1 here. The formal parameter then becomes 1. Inside the function before incrementing, n is 1. Now we increment n becomes 2. Inside the function after increment n is 2, but after the call, x is still 1. What makes this easier, I think, to understand is the fact that we use different variable names. Well, let's change that. Let's make all of this x. Let's make this x, 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 x. No harm in using the same variable name. In fact, I think it's probably better here to make sure we understand how this is working. Because now you might be thinking, oh no, but aren't we changing x here? Right? Didn't we send over 1 and now we're changing x to become 2? We did. X became 2. But we see after the call, x is still 1. Well, how is that? Debugging will give you the answer. When you debug this, here we go, Python says, okay, I see you have an increment function. I see you have a main function, cool. Let's call main, great. Here's main. And now in this main function, we have what? We have the variable x equals 1. So notice this is a local variable, x is 1. And you know what? Let me turn off the heap. So view, let me turn off heap so we can actually see the values of x because it was showing us an address. Let's debug that again. All right, so x is 1. Here's the value. Before the call, x is 1 is what gets printed, as we would expect. Now we're going to call increment x. So we're going to send over 1, which is the local, which is the actual parameter. And we're calling this increment function with the value 1. So here x was 1, as you can see. And inside the function before increment, we're going to print x is 1, absolutely. Right? This is what gets printed. And move this up. Now x becomes 2. Look, notice x right here is very clearly 2. And we will print now inside the function after incrementing x is 2. Absolutely, that will get printed. X is 2. Very clear. Make no doubt about it. You can see right here x is 2. But here's what's important. Look at this other function, which is on pause, this main function. What is x over here? X is still 1. This is why the debugger is awesome. X is still 1. So even though they have the same variable name, this x here is a local variable to this function. This x over here is a local variable to this function. Even though it's the same name, they are two different variables. And if you really understood that example of the call stack in those activation records, it would make sense why. Because really, when I come over here to the tablet, let me erase what's here. What happened here is we had this stack, right? And what happened is we called our main. Main opened up. And what was inside main? We had this variable x equals 1, right? Then we called the increment function. We called increment. I sent over 1. And this is our main function. So now we're calling increment. Here's increment. This is the increment function. Sorry, I'm trying to write messy and fast. X is 1. But then after we increment it, what does x become? X then becomes 2. And remember, all of this is what? It's on pause. But the important takeaway here is that we have an x here in this activation record, and we have a different x over here in that activation record. And so once the increment function right here, once it finishes, it will get removed from the stack, from the function stack. This is no longer on pause, and we're back at main. And what's the takeaway? The takeaway is x is still 1, which is what you can clearly see here when we're debugging this. So here x is 2 in this increment function, but once it finishes, we're going to go back to main, and we can already see that x is still 1 in main, which is why when we print after the call, we can see that we're going to print x is in fact still 1. Super, super helpful to debug this to get a full, solid understanding of what's actually happening in the code. So here's just a question. Consider this snippet of code. Ask yourself, how many objects do you think Python creates? Pause the video and think of this. How many objects are getting created when we run that code? 4 lines of code. X is 2, x equals 3, y equals x, y plus equals 1. How many objects are getting created? Pause the video, spin 60 seconds, come back. The answer is 4. If you said 3, you were close, because we now know we're going to make this object 2. We're going to save its address into X. We're making another object 3. We save its address into X. We're going to save whatever's in X into Y, which is just an address, so no new object was created there. And you might be thinking that we're just going to add 1 to Y, which is 4, and that will be the third object. So you'd be close. But when we want to add 1 to Y, what actually happens is first an object is created with the value of 1, right? An object is created with that value of 1. We then add that value 1 to the 3. We get the answer of 4, save it into Y, and we see that 4 objects were actually created. Super funky. Here, another snippet of code, really just trying to demonstrate those addresses and what's saved inside X and Y here. And we can print, we saw way earlier in a previous video, that we can actually print out the ID of a given variable. And what is this ID function in Python? Well, let's go take a look at it. If I come over here to my garbage, let's erase all of this. I'm not going to make a main, pardon me. I'm just going to type x equals 7, print the ID of x. Let's run this code. When we run the code, this is the ID of x. And you might be wondering, oh, what the heck is that? Well, let's see. Let's come back and view the heap. And let's remember, when I debug this, and I come over here, this is the assignment. We take the value 7, we make an object that gets saved into this address in memory, and this address is what's actually saved into X, as we see up here. And now we're saying print the ID of X, and it prints this thing right here. Well, what is that number right here that's printed? The ID of X. This is a Python function. Well, what is this number? It's the address. This is the exact same number as this number right here. It doesn't look the same, you might be thinking. This has 1CE925. Well, it's because this number is hexadecimal and this number is decimal. And if you want to see to confirm that, we can come to our browser. We can come to a conversion website, Rapid Tables. You can just type in convert hexadecimal to decimal, and let's type in this exact value. 1CE925. 925 D01 B0. And again, what does this number represent? Let me make sure I have this right. 1CE 925, 1CE 925 D01 D01 B0. What does this hexadecimal number represent? It's the address on the heap where this object with the number 7 was stored. And so ID, it's just important to know it's a function that will tell you that exact address, but it gives that address in decimal form. So now when I come here and I hit convert, we see 1986.730, 1986.730, 459, 568, 459, 568. So kind of cool. Does that help improve your life? Probably not. But nevertheless, we cover it and we want you to see what that ID actually does. And it's important here because in this example, we see X is 4, then we say take X and save it into Y. Well, the consequence is that now X and Y will have the exact same address. That's what's important, just to really see what's going on. Also, new for us is this idea of keyword-based arguments. What we've seen thus far is simply what is known in Python as positional arguments. There are two kinds of parameters in Python. We have positional parameters, positional arguments. We also have keyword arguments. Positional arguments are what we've been using thus far. It simply means that when you send arguments to a function, those arguments must be in the exact same order as their respective placeholders in the function header. If you send over 3 parameters as actual parameters, well, you need to, the formal parameters in this function header must be 3 parameters. If you send over with those 3 parameters, a string followed by an integer followed by a double, Well, in your formal parameters, you should have first a string followed by an integer followed by a double. It's super important to understand that. So here, imagine that we had this basic function. We make our own print function. We have a built-in print function, which does what? It takes whatever's inside the parameters and it prints it to the output. Here, we make our own print function called inprintln. Basically, this function is going to take a given string message and it will repeat it and print it n times. So if n is 4, it would just loop 4 times and print that message every single time. So if we called this function with 2 parameters, the first parameter is the string hello, the second parameter is the number 3, the result would be we would print hello 3 times on 3 different lines. I think any listener right now understands that, right? It's pretty clear. The word hello is going to be sent over and saved inside this variable message, and the number 3 gets saved inside n. We then say for I in range 3, print message, which is hello, and we print hello 3 times. Pretty clear. Here's what's important though. Could we have called this function and sent over the parameters like this? The answer is absolutely not. So if we sent over the 3 and 3 got saved into message, and then the word hello got saved into n, that's not a problem. It's weird, but it's not a problem yet. But now when I say for I in range hello, that wouldn't work, right? It doesn't make sense. So the takeaway here is we were expecting a string followed by an integer, the number of times. So when we call the function, in the actual parameters, we need to send over a string followed by an integer, right? This is the idea. So for positional arguments, which is what we've been using thus far, the arguments must absolutely match, meaning the actual parameters must perfectly match the formal parameters with respect to 3 things: their quantity, the order of them, as well as their compatible type. Now, Python also allows you to do what is called keyword arguments, which is honestly super funky. But keyword arguments is that you can name each argument. So I could call the function like this, inprintln, and I can say n equals 3, message equals hello. So now the real argument is 3 and hello, right? Those are the 2 parameters, 3 and hello. But by naming them like this, using the variable names from the formal parameters, now the order doesn't matter. So Python allows you to do this idea of keyword arguments, but to be honest, it's not very commonly used. And I suspect that's also because many languages don't have that. And so usually Python developers, they'll develop in a more general fashion following standard paradigms from other languages. So keyword arguments, it's allowed in Python, but it's something that usually people just stick with traditional positional arguments. Let's solve a problem. Roll dice game. Write a program to simulate 2 users rolling a pair of dice. You should print the result of each player's dice roll along with who won, or if there was no winner, to print that it was a tie. So for this program, we need to write a main function. We also need to write this roll pair dice program. So what's the first thing we need? Well, if we want to roll a pair of dice, we need random. We need to randomly choose a value of a 6-sided dice from 1 to 6. That simulates 1 dice roll, and we want to do that twice. We want to simulate 2 independent dice rolls, so 2 independent randoms from 1 to 6. We also then need to have a main that's going to, inside our main, we're going to simulate the rolling of the dice of player 1. We're going to simulate the rolling of the dice of player 2, and then we're simply going to print out who wins, and we're going to print something like this. So let's go code this one up together. I'm going to come over File, New, Save, Chapter 6, and let's call this Roll Dice Program. And let's see. So we need to have this function. What was the function called? Roll pair dice. Define roll pair dice. And before we can even do this, of course, we need to do what? As we mentioned, import random. Now this roll pair dice function, it's simply going to return It's going to simulate the rolling of 2 dice. It's just going to return a random 1/6 plus another random 1/6. So return random.randint 1,6 plus random.randint 1,6. That's all this is doing. Notice it's even called roll pair dice. It has no parameters. We're just trying to simulate you roll 2 dice out, maybe you get a 2 and a 5, for example, for a total of a 7. So now we have our main. And what should our main do? Our main is going to, as we mentioned, we're going to simulate those 2 players and their scores. So score of player 1 equals roll pair dice. And we're going to do the same thing for score of player 2. Roll pair dice. So now we've rolled the dice for both players. And now we just want to print the results. And before I forget, let's come over here and call the main. So we want to print the results now. So we want to print player 1 rolled a blank and player 2 rolled a blank. So player 1 rolled a this and player 2 rolled a this. Dot format. Let me zoom out so we can see. And this is score player 1, score player 2, and then finally we need to print player 1 you win, player 2 you win, and so on. So this is easy. So just if score player 1 is greater than score of player 2, I'm going to copy paste, make my life easier. Print player 1 you win. Elif, I'm going to basically do this here. If score of player 2 is greater than score of player 1, player 2, you win. And then finally else, print it's a tie. Something like that. So that was quick. I hope you paused the video, tried to code it up yourself, but I'm looking at the time here, so I'm trying to go through this one. This is pretty straightforward, but it's just more practice with functions. Player 1 rolled a 9, player 2 rolled a 4, player 1 you win, player 1 roll, let's do it again, let's get player 2 winning. Come on, player 2. Player 1 rolled a 3, player 2 rolled an 8, player 2 you win. Can we get a tie? And there's a tie, they both rolled a 10. Cool. So here we had this basic function, roll pair dice. Pretty easy, just returns the simulation of rolling a pair of dice. And here we have our main function and our call over to main. Final thing here on the slides is just talking about the main purpose of functions. What really is? This is an important question. Don't ever hesitate. What's the main purpose of functions? It's a lesson in recycling, in being green, in code reuse. We want to write code one time and reuse it over and over and over. A second purpose of functions is modularization, this idea that by taking a really large program, but now pulling out components of it, like modules of it, it makes it easier to read. You have some long program that has maybe little organization, some huge, long, 1,000-line block of code, but if you can break it into maybe sections and functions and pull out those functions, it makes it a bit more palatable and easier to read. This is the idea of modularizing one's code. And a benefit of modularizing your code is you can also take that code that does something specific, a function, and you can actually put it into an independent file and remove it from your main working file altogether and import it and only use it when you need to use it. So here we have that GCD program that we wrote previously. It's a function, it takes 2 numbers, and it then returns the GCD of those 2 numbers. I won't go through this code here. You can pause the video, try to make sure you remember the code, but we've solved this one. So here's this GCD program. What I can do is I can take all of that code and I can offload it into its own file called gcdfunction.py. So I've already done that here. So gcdfunction.py, it's right here. There's no main. I'm not calling the function. I'm only putting the function over here in the file. And so now look what I have. I make another program called test GCD function. And inside this test GCD function, I import from this file the actual function I want. I type from GCD function, which is the name of the file, import GCD, which is this entire function, and now guess what? I can just use it. I have my main, I have num1 and num2 that I scan from the user, and I print the GCD of blank and blank is blank. And this third parameter is I'm calling the GCD function, which is off in another file, which is super cool. So when I run this, enter a number, 24, enter another integer, 16. The GCD of 24 and 16 is 8. Super cool that we're calling that from another file. I went over that quickly, but it's not much to really harp on. It's just the idea we can offload, we can modularize our code, offload components into another file, and then import what we need, specific functions from them. Super valuable. So the main component, the main value of functions is code reuse, but also a secondary value is to clean up your program and to actually modularize it, and if you like, to offload certain components into another file. And guess what? Let's go. We're done. I'm a minute over. I wanted to always keep these under 45 minutes. As always, reach out if you need anything. Take care, everyone.